Hello and welcome to episode 1 of our Let's Make a Game series, where we're going to be making a 2D platformer game. If you have not watched episode 0, our introduction video, make sure to go do that now, or else nothing will make sense. Well, some stuff might, but the premise of the game won't. To start off, let's make a tiles folder, and let's make a quad on the screen. Reset the position, and create a material, call it stone, and set its albedo color to gray. Drag the stone onto the quad, and make sure in the stone material to set the smoothness all the way down. The quad will rename tile stone, and it will be dragged into our tiles folder as a prefab. We're going to rename this tile dirt, and drag it in as another prefab. Create a new material, dirt, make it brown, and apply it. Firstly, set its smoothness all the way down, apply it to tile dirt, apply tile dirt to its prefab. Then we're going to make tile grass, add it as a new prefab, new material, call it grass, smooth this all the way down, and we'll make it not red, green. That's a little too bright. Let's make it darker green. Apply grass to tile grass, apply that to the prefab, and we can delete it from the scene. Now we're going to need the script that actually generates the world. So create a folder, call it scripts. Inside we'll make a new C# script and call it generate chunk. The world is going to split up into chunks, so that way we don't have to generate anything too large at once. We don't need these comments, and we don't need an update function. So we'll rename the update function to generate function. I will make it public so it can be called from elsewhere. And in start, we'll just generate. We also need public int width, public int, float, height multiplier, and then we can for int I equals 0, width I plus plus. We also need our tiles, so we could do this as an array, but we're not going to, just so we can have stricter spawning rules. So game object dirt tile, public game object grass tile, public game object stone tile. We're also going to for int j equals 0, j is less than width, j plus plus. Then we're going to int h for height equals mathf.round to int let's see, I divided by 3. We're going to want to divide by 3. Mathf.Perlin noise. I divided by 3, so the Perlin noise doesn't return the same result. I divided by 3 and 0f. Yeah, let's do this the other way. 0f, I divided by 3. And then close that off. J, and then instead of j is less than width, j is less than h. And instantiate selected tile. Okay, we're going to need a selected tile. Selected tile. New vector 3. J, and if you don't provide a z component, it will default to 0. And then quaternion.identity. Then we just need a simple rule for determining whether a tile is spawned as a grass, dirt, or stone. If J. Alright, let's move this in here. If J is less than H minus 4, selected tile equals stone tile. Else, if J is less than H minus 1, then selected tile equals dirt tile. And otherwise, if we put another if in here, there will be some situations, there may be some situations where there's no selected tile. Selected tile equals a grass tile. Alright, let's add this, save it, then add it to a handler game object, which is just going to be an empty handler. Reset at the origin. Circle around it. It's interesting. Alright, add generate chunks. Go into our tiles folder. Assign the dirt tile. Assign the grass tile. And the stone tile. Let's first generate only about 50 wide and height multiplier of 3 or so. That's odd. Width is 50. I equals 0. I is less than 50. H equals... okay. H. Vector 3. I and J. Are they being instantiated? Hold on, I'm going to figure this out and be right back. Alright, so I figured it out. It's returning 0 every time, so the Perlin noise is always coming back at 0. So maybe if we make it 1F, that will make the difference that we need? No. It's very strange. Okay, instead of debug.logging H, well, not mesh, we'll debug the Perlin noise that it generates. Odd. Maybe this times height multiplier, like that, and maybe now we'll get something that works. Perfect, although it's just a flat field of grass. So maybe if we increase it to 10, we'll get... okay, so it's partially working. I think oh, I see the problem. Our dirt has the stone material on it. Grass has grass, stone has stone. So now it should generate this. Alright, so that's only 1 quad each. It's returning the same number each time, so I divided by 3. Oh, just I. Perlin noise is sometimes a bit irritating to work with, and this is one of those times. Divided by 3. So it only returns divided by 3F. Of course, because if you put an integer into the Perlin noise, it returns at 0.46. There we go. Simple terrain generation, just like that. It's a little steep though. So times smoothness, and then we're going to have public float smoothness. Not other capitals. smoothness. So then we're going to set smoothness to 5, like this, and run it, and that's still odd. Maybe if we multiply both sides. Part of programming is experimentation, and it also is generating the same terrain every time. So we're going to have int seed. Seed equals random dot range negative 10,000, 10,000. All non-floats. F plus seed. And run it. So we shouldn't get the same result, but we are. So mathf.perlin noise, 1f plus seed. Maybe just not 1f plus seed. Seed equals random.range. So we have a working terrain of some sorts. So it's generating a different terrain, but Perlin noise seed equals random.range float seed. Let's just use floats because we're rounding it to an int anyway. Come on. Okay, so sometimes it works, but for now, let's worry about height addition. We're going to want this whole thing to be off the ground. So that way we don't have to deal with holes in the world sometimes. So with height addition 0, it's the same that we had before. But if we add 10 to the height, we should get 10 blocks of stone under everything. And there we go. It's a very simple terrain system that generates one chunk. Alright, so I think I figured out the smoothness. Instead of dividing by 3, we'll divide by smoothness. And then if we make the terrain a bit smoother, compiler error, 25, 29. So we're just missing a... Oh, there's an extra star there for some reason. And there we go, much smoother terrain. If we turn down the smoothness, we should get a bit rockier terrain. Alright, if we set smoothness to 1, we should get very, very odd terrain. Yes, it's all smooth because it's integers. Set it to 2, we get very bumpy terrain. And if we set it to some huge number in this context, we should get very smooth terrain. So there we go. That's our system for generating one chunk. Let's just find a good default value here. Yeah, that would be good for building. So width, I'm thinking of shrinking the chunks to a width of only 25 or so to make the maths a bit easier and the chunks save more nicely. Thank you for watching this episode, and be sure to tune in next episode for more development. And be sure to show your support on Patreon.